In this video, we're going to graph linear equations by utilizing slope and y-intercept. So you should have this handout in your possession. If you don't, make sure you go print it off from Classroom or see me for a copy later on. If you don't have a copy and there's no way for you to get one right now, just follow along. You can always fill it in later and make it a part of your notes at a later date. So for each of these graphs, you'll notice that they are written in y equals form. And what we've done is we've created an accurate graph of these. And on your handout, you can actually see the coordinates because you can see the tables, and I could fit them on your handout of the points that you see on the screen. So what we're going to do for each of these graphs and equations is we're going to find the y-intercept for each one, and then we're going to find the slope. So I'm going to start with the y-intercept, and while I could calculate this by putting 0 in for x, because we know at the y-intercept point, x is always 0, I can just find this visually by looking at the graph. So I know that the y-intercept occurs when I cross the y-axis. So here I see x is 0, y is -1. That's my coordinate for my first graph. The next one I see is that x is 0, y is 3. The next one I see is x is 0, y is 1. Then from here, I want to calculate my slope for each graph. And again, you can calculate this using the slope equation if you would like and the points in the tables, or we can just count this visually. So here we're going to go up 1, 2, 3. So my slope has a rise of +3 and then a run in the +1 direction of +1. So my slope is 3 over 1, or just 3. Then for the second graph here, I'm going to go down 1, 2, so that's a rise of -2 over a run to the right of +1. So I have a slope of -2 over 1, or just -2. And then finally here, I have a slope that goes up 1, so I can see it goes up a +1 in the rise direction, and then it runs a +2 in the run direction. So I have a slope of a +1/2. So what we need to do at this point is we need to look at this key information, and we then need to make an observation about how these pieces of key information down here relate to our equations up top. And I'm going to focus first on the y-intercept points. So here I see y-intercept is a -1 here, a +3 here, and a +1 here. And when I look up at these three equations, what I notice is that -1, 3, and 1 are all a part of these equations. We have -1 here, +3 here, and a +1 here. So what I'm noticing is that the y-intercept, that y-intercept point, when this is written in y equals form, that y-intercept point is the constant number, or if you want a less mathy term, a number without a variable. So when looking at all three of these equations, what I'm noticing is if I get y alone, the constant, or the value without a variable, can be associated with my y-intercept value here. So that's kind of a cool relationship. I have y-intercepts that are found right in my equation. Now, if I flip gears here and I focus on the slope, so if I focus on slope instead, I notice slope here is 3, slope here is -2, and slope here is 1/2. Well, when I look up at my equations, what I see is that slope is found right next to x. So what's really cool about this y equals form is if we get y by itself, that constant term is our y-intercept, and then our slope of our graph can be found by taking the coefficient of x. So we're going to learn in this video how to use those values to our advantage to create a linear graph very, very quickly. So this form that we saw in the previous slide is more formally known as slope-intercept form. And slope-intercept form occurs when we have y alone. So this is called function form. And then once it's written in function form, our slope is the number in front of x, so that's the coefficient of x. And our y-intercept here is our constant value without the x. So this is commonly known as slope-intercept form. You'll also hear it as y equals mx plus b. So what we're going to do in these examples down below is we're going to identify the slope and the y-intercept in each equation. So if I look at this first example here, I'm going to find my slope and my y-intercept. My slope, I know, is the coefficient of x. So here, if I look for the coefficient of x, I notice that the number in front of x is 3. So here my slope has a value of 3. And if you like to write it as a fraction, you can write it as 3 over 1. Either is fine. Then my y-intercept point is my constant. Now I'm going to use keep, change here so that I can make sure I see that my y-intercept point is this constant value of -6. So my y-intercept is occurring at x is 0, y is -6. Now if I move on and I'm going to go down below, I'm going to kind of go counterclockwise here. So I'm going to start down here. I'm going to look for slope and y-intercept again. So my slope, remember, is the coefficient of x. So here I can see, I'm going to use keep, change. My coefficient of x is the number in front of the x. So my slope is actually a -3/4. So it's not always first. Your slope is the coefficient of x. Your y-intercept is then the constant value, which here I can see is -2. So my y-intercept occurs when x is 0 and y is -2. Then if I look at the next example, here I can see that I have a situation where I can utilize keep, change. And then I need to identify my slope and my y-intercept. So my slope is the coefficient of x, which is the number in front of x, which here is -2. If you want to write that as a fraction, you can write it as -2 over 1. And then my y-intercept point is my constant value here, so this 4. So my y-intercept is occurring when x is 0 and y is 4. Finally, this last example here, this one's a little bit tricky because of the way that it's written. Remember that if there's not a number in front of the x, that they're implying that there is a -1 value there. So what this is really saying is you have -1x, and then we can find our slope by looking at the coefficient of x, which we can see here is -1. And if you want to write that as a fraction, it's just -1 over 1. Now, our y-intercept point is also a little bit tricky in this particular example. So the y-intercept point here is not none. Just because you don't see a plus something doesn't mean that there isn't a y-intercept. So here what we need to think about is what number could possibly be there as the y-intercept. And what I think about is the only number that I could add in there and not change the value of the equation is 0. If I do a +0, I don't really change the value of anything. I'm just writing in a +0. And what that's telling me is if there isn't a number there for the y-intercept, my y-intercept is really the point 0, 0. So that last one is a little bit tricky, but for the rest of them, your slope, you're looking at the coefficient of x, and then your constant is your y-intercept value. So what we're going to do at this point is we're actually going to start graphing by utilizing slope-intercept form. So our first step when we utilize slope-intercept form is we need to remember that slope-intercept form is y equals mx plus b. So what we need to always do first is we always need to rewrite our equation so that the y value is alone and that it's actually in slope-intercept form. So here in this example, we have 2x plus 3y is equal to 12. And we want to rewrite this equation so that y is by itself. So the first thing that we need to do is we need to subtract 2x from each side. And in doing so, this is going to become 0. And then on the left-hand side, we're left with 3y is equal to, we're just going to write 12 plus a negative 2x, because those are not alike terms. Then from here, I need to divide each side by 3. So I end up with y is equal to 12 divided by 3 is 4, plus a negative 2 over 3 times x. So now that I have it written in slope-intercept form, I can identify the slope and the y-intercept point. So my slope, remember, is my coefficient of x. So here I can see that my coefficient of x, the number in front of x here, is a negative 2 over 3. Then from here, my y-intercept value is this constant value over here, the constant by itself. So my y-intercept value is x is 0, y is 4. I'm crossing the y-intercept at the y value of 4. So now that I have this key information, I can go to my graph and I can actually start plotting. So the first thing I'm going to do is I'm going to plot my y-intercept point, because I know that that is a specific point on my line. So here I'm going to go to x is 0, y is 1, 2, 3, 4. So we have x is 0, y is 4. Then from here, I can use my slope to help me plot additional points. So remember that our slope is really the equivalent of our change in y, which is our rise, and our change in x, which is our run. So we're talking about our vertical change over our horizontal change. So right here, this negative 2 represents our vertical change. And this is saying that we're moving vertically in the negative direction 2. The negative vertical direction is down. So this is telling me that I need to go down 2 points. And then this 3, because it doesn't have a sign next to it, is actually plus. So then we're going to move in the positive horizontal direction, which is to the right, 3 points. So to find an additional point, we're going to go to this 0, 4, and then we're going to follow this pattern. We're going to go down 1, 2, and then to the right 1, 2, 3, and plot our point. So a second point on our line by utilizing our slope is x is 3, y is 2. And then I can take that same pattern and go down 1, 2, to the right 1, 2, 3. So I have another point at x is 6, y is 0. Now once I see this pattern, I can also apply it backwards by going up 1, 2, and then backwards 1, 2, 3. To find that I have a point at x is negative 3, y is 6. So I can use that slope pattern to help me actually plot additional points to go on my graph. Now from here, all I need to do is connect my points, and I can draw an accurate line. I'm going to connect them all, put an arrow on the end, go all the way through the coordinate plane. So now I have a nice accurate representation of my line. All of those points on that line are what make this equation true. Now the final thing I need to do is I need to actually determine my domain and my range. Because my graph is going forever to the right and forever to the left, my domain is all real numbers, and my range is going forever up and forever down, so my range is also all real numbers. So next example here, I notice that this one is already written in slope-intercept form. So I actually don't have to rewrite it. So it's already been written correctly. We already have y by itself. So what we can start off doing right off the bat, because it's in y equals mx plus b form, is we can actually start by identifying our slope and our y-intercept. So remember, our slope is the coefficient of x, which in this case I can see is 1 over 2. And then my y-intercept point, I'm going to use keep change here, is my constant value, so negative 5. So my y-intercept is occurring when x is 0 and my y value is negative 5. So in order to graph this on my coordinate plane, I'm going to start by going to my y-intercept value. So I know that I'm crossing the y-intercept when y is negative 5, so I can go plot 0, negative 1, 2, 3, 4, 5. So I can plot that point. X is 0, y is negative 5. Then from here, I need to plot additional points utilizing my slope. And remember, slope is my rise over run. So since these don't have symbols, that's implying that both of these are positive values. So what this is saying is we're going to move 1 in the vertical direction, and we're going to move 1 in the positive vertical direction, which means we're going to go up 1. And then we're going to move 2 in the positive horizontal direction, so we're going to go to the right 2. So that pattern of up 1, right 2, up 1, right 2 is going to help us find additional points. So we're going to go up 1, right 1, 2, and plot. So we're at x is 2, y is negative 4. Then we go up 1, right 1, 2. So we have another point. X is 4, y is negative 3. And we go up 1, right 2. So we have an additional point. And then that point is x is 6, y is negative 2. We can also apply that pattern backwards. We'd go down 1 and to the left 2. So that would be the point x is negative 2, y is negative 6. But already here you can start to see a really nice representation of our graph. So then we connect all the points, putting arrows at the end as we extend through the entire coordinate plane. And then finally we need to determine our domain and our range. Since it's going forever left and right, our domain is all real numbers. And our range, because we're going forever up and forever down, is also all real numbers. So third example here, we're going to start by getting this into slope-intercept form. So remember we need y alone, so y equals mx plus b. So we need to get this y value completely by itself. To start, I'm going to utilize keep change change to prevent any errors. And then I'm going to start rewriting this equation for y by itself. So I start by adding the 6x to each side so that those cancel out there. And we're left with negative 2y is equal to negative 12 plus 6x. And since they aren't like terms, I do not combine them together. Then I'm going to divide both sides by a negative 2. So I have y is equal to negative 12 over negative 2 is 6 plus, here we have 6 divided by negative 2, which is a negative 3x. So we now have this rewritten for y by itself. Now our next job is to determine our slope and y-intercept of this line. My slope, I know, is the coefficient of x, so I'm looking for the number in front of x. And here I notice that my slope is negative 3. And I know that I'm going to be plotting my slope later. So remember, we can turn any integer into a fraction. So we can turn it into rise over run by simply putting it over 1. Then from here, my y-intercept is the constant term by itself, so that's simply 6. And we're going to have our y-intercept point be at x is 0, y is 6. So I'm going to go over to my graph and plot my y-intercept, which is occurring at x is 0, y is 1, 2, 3, 4, 5, 6. So x is 0, y is 6. Then I go over to my slope, and I notice that it's negative 3 over 1. So I know my rise, I'm moving down in the vertical direction 3. And then my run, I'm moving to the right in the positive direction 1. So to find additional points, I go down 1, 2, 3, right 1 to the point x is 1, y is negative 3. Down 1, 2, 3, right 1 to the point x is 2, y is 0. Down 1, 2, 3 to the right 1, so we have x is 3, y is 3, and then we could continue that pattern, but here I can see I have a pretty good shape of what my line looks like, so I'm going to connect the dots, extend it fully through my coordinate plane, and add arrows onto the end. Then to end, I need to determine my domain. Because it's going forever left and right, my domain is all real numbers. And because it's going forever up and down, my range is also all real numbers.